Today's topic is unemployment. This is a bit shorter and less difficult chapter, so I can cover rather quickly than usual. In this chapter, you'll learn about the natural rate of unemployment, what it means, what causes it, and understanding its behavior in the real world. The natural rate of unemployment is the normal unemployment rate the economy experiences when it is neither in a recession nor in a boom. Basically, the natural rate of unemployment is the average rate of unemployment around which the economy fluctuates. And in a recession, the actual unemployment rate rises above the natural rate, and in a boom, the actual unemployment rate falls below the natural rate. So as you see in this plot, the actual unemployment rate fluctuates considerably over the short run. And the short run fluctuation will be dealt with in chapter 10 and on, and here we focus on long run trend in the unemployment rate, that is the natural rate of unemployment. So now let's explore the first model of the natural rate by defining the notations. L is defined as number of workers in the labor force. E is defined as number of employed workers. U is defined as number of unemployed. And finally, U over L is defined as the unemployment rate. Here we assume three variables to be exogenous. L, the labor force, is exogenously fixed. And 2, during any given period, for example, a given month. S, the rate of job separation, is the fraction of employed workers that become separated from their jobs. F is the rate of job finding, that's the fraction of unemployed workers that finds jobs. And we assume S and F are exogenous. This diagram depicts the transitions between employment and unemployment. And in every period, a fraction S of the employed E lose their jobs. So S times E is the number of people losing jobs. Also, a fraction F of the unemployed U find jobs. So F times U is the number of people finding jobs. Therefore, the rates of job separation S and job finding F determine the rate of unemployment, U over L. And in order for the unemployment rate to be constant, the number of people who become unemployed in each month must equal the number of formerly unemployed people who find jobs. In other words, the steady state condition is, that is, in a steady state, the number of people finding jobs equals the number of people losing jobs. Now, from the steady state condition, we can derive a formula to finding the equilibrium unemployment rate. So at steady state, F times U equals to S times E. And since L, the labor force, equals to E plus U, so if you solve for E equals to L minus U. So I can substitute for E, L minus U on next step. And then I can separate this into two like this. That is S times L minus S times U. And that should equal to F times U. Therefore, F times U equals to S times L minus S times U. And in order to solve for U over L, what I can do is gather all the U terms to one side. So I gather all the U terms to the left-hand side, and then factored, and I get left-hand side F plus S times U. And on the right-hand side, what's remaining is S times L. And final step is dividing both sides by L, and also dividing both sides by S plus F. Then I can derive this equation. That is, the natural rate of unemployment should equal to, that's U over L equals to S over S plus F. So now we express the natural rate of unemployment in terms of both exogenous variable S, the rate of job separation, and F, the rate of job finding. Now let's look at an example. Suppose in each month, 1% of employed workers lose their jobs, and 19% of unemployed workers find jobs. Then the rate of job separation S equals 0.01, and the rate of job finding F equals 0.19. Based on this information, find the natural rate of unemployment, that is the long-run equilibrium rate of unemployment. So why don't you take a moment, like half a minute or 1 minute, and try to solve this question. Okay, now I assume you solved the question. So what's the answer? So what's the equation you use? U over L equals to what? Alright, that's equal to S over S plus F. So if you substitute S 0.01, that is, and F 0.19, then what you get is this. That is 0.01 over 0.01 plus 0.19 equals to 0.05 or 5%. That means we found the natural rate of unemployment to be 5%. Now, what is the policy implication according to this model? So according to this model, a policy will reduce the natural rate of unemployment only if it lowers S or increases F. That is, because U over L equals to S over S plus F, when you lower S, then you can lower U over L. Similarly, if you increase F, you can lower U over L. So you can use that equation to figure this out. Or you can express that equation by dividing both top and bottom by S. Then you can re-express that equation as U over L equals to 1 over 1 plus the denominator inside the parentheses F over S. So if you wrote it that way, you can also make it easy to find how decreasing S would actually decrease natural rate of unemployment. So why don't you write this down and try to figure this out again by yourself. Now let's stop for a moment and try to answer this question. Why is there unemployment? If job finding were instantaneous, F equals 1, that is, all who seek jobs find them, then all spells of unemployment would be very brief, and the natural rate would be near 0. And there are two reasons why F is less than 1. One, job search, which is related to so-called frictional unemployment. And two, wage rigidity, that is related to structural unemployment. For example, there's always a lot more applications than open positions. That leads to wage rigidity or structural unemployment. Let us look at each case. First, the job search or frictional unemployment case. The frictional unemployment is caused by the time it takes workers to search for a job, and it occurs even when wages are flexible and there are enough jobs to go around. And this occurs because, 1, workers have different abilities and preferences, and 2, jobs have different skill requirements, and 3, geographic mobility of workers are not instantaneous, that is, it may take time to relocate, and 4, flow of information about vacancies and job candidates is imperfect. Now let's look at an important reason for a frictional unemployment. Economists define sectoral shifts as changes in the composition of demand among industries or regions. For example, technological change that create more jobs repairing computers while causing fewer jobs repairing typewriters. Another example, a new international trade agreement may lead to labor demand increases in exporting sectors and decreases in import competing sectors. And these scenarios result in frictional unemployment, and sometimes the unemployment caused by sectoral shifts can be severe. For instance, due to increase in imports of cheaper foreign-made textiles, particularly since the expiration in 2005 of long-standing quotas on textiles from China, the US textile industry has been in decline for years, and tens of thousands of workers lost jobs in this industry. These pie charts depict industry shares in the US GDP in 1960 versus in 2012. And here, other industries includes construction, mining, electricity, water, and gas. And from 1960 to 2012, there are huge changes in all 4 sectors categories. First, manufacturing falls over half, and second, agricultural sector share drops by about 3/4. Remember, sectoral shifts are changes in the composition of demand across industries, and as a result of these huge sectoral shifts, the types of jobs available now are vastly different than just 2 generations ago. Here are more examples of sectoral shifts. And these are the big changes that have occurred over many years. First is Industrial Revolution in 1800s. At that time, agriculture declines, manufacturing soars. And second is Energy Crisis of 1970s. At that time, demand shifts from larger cars to smaller ones. And third is healthcare spending as percent of GDP. That has been changing, as you see, from 1960 to 2010, for example. So in 1960 was 5.2%, then by 1980 it became 9.1%, and due to aging population, you can see it's keep increasing. By 2000 it becomes 13.8%, and finally 2010 it became 17.9%. Perhaps more important for the natural rate are small changes that occur more frequently. So in our dynamic economy, smaller sectoral shifts occur frequently, contributing to frictional unemployment than these large changes that I listed. Due to what? Preferences changes, technological change, and the location of production. These may contribute to frictional unemployment. In order to decrease the natural rate of unemployment by reducing frictional unemployment, government may provide government employment agencies, which disseminate information about job findings to better match workers and jobs. Also, government may provide public job training programs, which are instituted to help workers displaced from declining industries get skills needed for jobs in growing industries. So these government programs may affect unemployment by helping them to find jobs easier and faster than otherwise. On the other hand, some government programs actually increase the natural rate of unemployment. One such example is the unemployment insurance. So unemployment insurance pays part of a worker's former wages for a limited time after losing his or her job. And unemployment insurance increases surge unemployment because it reduces, one, the opportunity cost of being unemployed, and two, the urgency of finding work, and three, F, the rate of job finding. And studies found that the longer a worker is eligible for unemployment insurance, the longer the duration of the average spell of unemployment. Therefore, it should be limited. However, there are also benefits of unemployment insurance. That is, by allowing workers more time to search, unemployment insurance may lead to better matches between jobs and workers, which would lead to greater productivity and higher incomes. Now, the second reason not all who seek jobs find them is due to wage rigidity, that is, structural unemployment. Wage rigidity is the failure of wages to adjust to a level at which labor supply equals labor demand. As you see in this model, if real wages stuck above the equilibrium level, then there aren't enough jobs to go around. This will lead to unemployment because the amount of labor that's willing to work, that is, labor supplied, is larger than the amount of labor hired, that's labor demand. So quantity demanded of labor is less than quantity supplied. So there's more supply than demanded, therefore there's excess supply of labor, and that's the structural unemployment. So if real wage is stuck above its equilibrium level, then there are not enough jobs to go around. Then firms must ration the scarce jobs among workers, and this leads to structural unemployment. That is the unemployment resulting from real wage rigidity and job rationing. There are three main reasons for wage rigidity. One, minimum wage laws. Two, labor unions. And three, efficiency wages. Let's look at each of those three cases. First, the minimum wage. The minimum wage may exceed the equilibrium wage of unskilled workers, especially teenagers. And studies found that a 10% increase in minimum wage reduces teen employment by 1 to 3%. But the minimum wage cannot explain the majority of the natural rate of unemployment, as most workers' wages are well above the minimum wage. Second, labor unions. Unions exercise monopoly power to secure higher wages for their members. And when the union wage exceeds the equilibrium wage, unemployment may result. And there are conflicts of interest between the insiders and outsiders. So who are the insiders? Insiders are employed union workers whose interest is to keep wages high. On the other hand, outsiders are unemployed non-union workers who prefer equilibrium wages, so there would be enough jobs for them. And the theory has two implications we can confront with data. First, union members' average earnings should be higher than non-union members' average earnings. And two, the difference between union and non-union wages should be higher in industries that are more heavily unionized than in less heavily unionized industries. So let's look at actual data to test these two implications. So we can construct the wage ratio, which is equal to average weekly earnings of union members over average weekly earnings of non-union members times 100. And by constructing the wage ratio, we can test the two implications I just mentioned. So based on these data of union membership and wage ratio by industry in 2013, we can test the two implications. The first implication, that union members' average earnings should be higher than non-union members' average earnings. And you look at the wage ratio to find that. For instance, if you look at private sector total, the wage ratio is 122.6. And if you look at government category, the wage ratio is 121.1. That means if you combine those two, you can say that union workers typically earn more than non-union workers, approximately by 22% more on average, because the wage ratio is approximately 122 when you combine those two. Similarly, for example, in transportation, 20.4% of workers are in unions, and on average they earn 23.5% more per week than non-union members in that industry. And testing second implication, we can see that in general, you see, the greater the percent of union workers in an industry, the higher the wage ratio. And if you actually find the correlation, you see the correlation is about 0.5 positive. So there's a positive correlation between these. So that means the difference between union and non-union wages should be higher in industries that are more heavily unionized than in less heavily unionized industries, if you look at the data here. Finally, efficiency wage theory. Efficiency wage theory is theory in which higher wages increase workers' productivity by attracting higher quality of job applicants, by increasing workers' effort, therefore reducing shirking, reducing turnover, which is costly to firms, and finally by improving health of workers, especially in developing countries. The best example of this theory applied is the Henry Ford's $5 working day in 1914. That's on page 195 in the textbook. So, firms willingly pay above equal wages to raise productivity. However, the result is the structural unemployment. Now let's briefly go through the US labor market experience. First, the median duration of US unemployment. So if you look at this chart, you can see that the duration of unemployment typically rises in recessions, but its rise in 2008 to 2010 is unprecedented. Now this table shows the duration of US unemployment from 1960 to 2009. So first column you have number of weeks unemployed. Second column you have number of unemployed persons in group. That is percent of all unemployed persons. And third, time spent unemployed by this group. That is percent of time spent unemployed by all groups. And there are three groups. First group, number of weeks from 1 to 4. Second group, number of weeks unemployed 5 to 14. Third group, number of weeks unemployed 15 or more. And if you look at the number of employed person in group, you can see that 42% of all unemployed persons are in the first group of 1 to 4 weeks, and 30% 5 to 14, and on 27% 15 or more. So you can see that number of unemployed persons in group declines as number of weeks unemployed increases in these three ranges. On the other hand, if you look at the last column, you see that the time spent unemployed by this group is actually largest by the third category, 15 or more weeks unemployed. That's 70.4%. That's over 2/3. Whereas 1 to 4 weeks, only 8.1%, even though as a percent of unemployed persons as a group is 42% largest. So the data we just saw show that more spells of unemployment are short-term than medium-term or long-term. And yet, most of the total time spent unemployed is attributable to the long-term unemployed. And this long-term unemployment is probably structural or due to sectoral shifts among vastly different industries. Knowing this is important because it can help us craft policies that are more likely to work. Unlike United States, if you look at this graph, unemployment in Europe has been rising significantly since 1960s. So this graph shows the plot of percent unemployed for major European countries. Includes Italy, France, Germany, and United Kingdom. And as you see, if you draw a trend line, you see a substantial increase in unemployment rate in Europe throughout those decades. Whereas in the United States, we have been falling unemployment rate. So what were the differences between the United States and Europe that caused this increase in unemployment in Europe versus not in the United States? Let's look at the different effects of a common shock. That is the technological progress which has shifted labor demand from unskilled to skilled workers in recent decades. And the effect is different in those two. One, in US, an increase in the skill premium increased the wage gap between skilled and unskilled workers. That is, the changes in demand is reflected in wages rather than unemployment. Whereas, the effect of the common shock in Europe was higher unemployment because the European nations had generous government benefits for unemployed workers and strong union presence. So generous government benefits for unemployed workers is related to increase in frictional unemployment, whereas the strong union presence was related to the increases in structural unemployment. So as you see in this table, the United States has very low unionization. That is, percent of workers covered by collective bargaining in US is only 12% in 2017. On the other hand, the major European nations had much higher percent of workers covered by collective bargaining or unions. For instance, United Kingdom has 30% of workers covered by collective bargaining, and Spain 78%, Germany 58%, France 98%, and Sweden also has 89%, but Sweden is an exception because in Sweden there is relatively more outsider influence through a special process of centralized wage bargaining at the national level, which may have led to the wage rate closer to equilibrium. On the other hand, the other Western European nations didn't have that kind of system, and that is the higher union presence led to more increase in structural unemployment. As you can see, this is a very big problem for France, which have 98% covered by collective bargaining.